Welcome to Flat Earth Not with John Houseman. I am not John Houseman. This is a reading from Geometry, Addison Wesley Series in Science and Mathematics Education, Secondary Mathematics Series from 1967. Pythagoras is generally regarded as the first of the Greek mathematicians, but very little is known about him as a person. He was born in about 582 BC and lived first on the Isle of Samos in the Aegean Sea and later in the south of Italy. Pythagoras and his students devoted themselves to mathematics, astronomy, and philosophy. They are credited with having developed geometry into a science. They proved the Pythagorean theorem, and they discovered the existence of irrational numbers. In astronomy, they were equally good. They knew in the 6th century BC that the earth is round and moves around the sun. They did not leave any written record of their work, and so nobody knows how they achieved these things or which of their discoveries were due to Pythagoras personally. Allow me to read that again. They did not leave any written record of their work, and so nobody knows how they achieved these things or which of their discoveries were due to Pythagoras personally. Next reading, page 261. How Eratosthenes measured the earth. The circumference of the earth at the equator is about 24,900 miles. In the 15th century, people thought that it was much smaller than this. Hence, when Columbus set out for India and landed on one of the Bahama Islands, he thought that he was already in India. Thus his margin of error was greater than the width of the United States plus that of the Pacific Ocean. In the 3rd century BC, however, the Greeks knew better. At that time, a Greek mathematician, Eratosthenes, measured the circumference of the earth, and his result was in error by only 1 or 2%. He devised the following method. It was observed that at Aswan, then called Syene, on the Nile, at noon on the summer solstice, the sun was exactly overhead. That is, at noon of this particular day, a vertical pole cast no shadow at all, and the bottom of a deep well was completely lit up. In the figure, C is the center of the earth. At noon on the summer solstice in Alexandria, Eratosthenes measured the angle marked A on the figure. That is, the angle between a vertical pole and the ray from the top of the pole through the tip of its shadow. He found that this was an angle of about 7 degrees 12 minutes, or about 1/50th of a complete circumference. Now the sun's rays observed on Earth are very close to being parallel. Assuming that they are parallel, it follows that when the lines L1 and L2 in the figure are cut by a transversal, alternate interior angles are congruent. Therefore, angle A is congruent with angle B. Therefore, the distance from Aswan to Alexandria must be about 1/50th of the circumference of the earth. The distance from Aswan to Alexandria was known to be about 5,000 Greek stadia. A stadium was an ancient unit of distance. Eratosthenes concluded that the circumference of the earth must be about 250,000 stadia. Converting to miles according to what ancient sources tell us about the length of a stadium, we obtain 24,662 miles. Thus Eratosthenes' error was well under 2%. Later he changed his estimate to an even closer one, 252,000 stadia. But nobody seems to know why he made the change. On the basis of the evidence, some historians believe that he was not only very clever and careful, but also very lucky. From the earliest times, geometry has played a leading part in applied mathematics. Egyptians needed it badly because the Nile overflowed every year, wiped out small landmarks, and thus created difficult surveying problems. Hence the word geometry, from two Greek words meaning earth and measurement. Later it turned out that geometry could be used not just to measure things on the earth, but literally to measure the earth itself. This illustrates a general rule: when good mathematics have been developed for one reason, it usually turns out to be good for other unexpected reasons. Very little is known about the work of Eratosthenes. We have some fragments of his books in the form of quotations by other ancient authors, but none of his own books have survived. The records indicate, however, that he wrote on nearly everything: geometry, astronomy, the theory of numbers, history, and comedy. He was also a poet. The Greeks called him Beta, the second letter of their alphabet, on the ground that he was the second best in everything, although not the very best in any one thing. His achievement in measuring the earth, however, was so spectacular that it was fully reported by others and rightly credited to him. The illustration shows a map of the world based on the ideas of Eratosthenes. Allow me to repeat this part. Very little is known about the work of Eratosthenes. We have some fragments of his books in the form of quotations by other ancient authors, but none of his own books have survived. This has been a reading not by John Houseman. Good day.